Morning. In today's session, we have to study about the network function. We will wait for other student for 1 minute. At that, we can review our previous session. In previous session, we have studied about the two-port network, a network which contains two pair of terminal. We are calling that network as a two-port network. जिसमें दो terminal है. How we will get the two terminals? If you see at any network, at the input port and output port, there are the terminals, and the terminals will be one terminal will be incoming at the input and one will be outgoing at the input. Similar concept for the terminal will be at the output, and in this way, if we will get one pair of terminal at input and one pair of terminal at the output, at that time we are calling that network as a two-port network. Then we have studied about there are different parameters available in the two-port network depending on the four variables. On which four variables? If we are having the two-port network, obviously there will be voltage and current for two networks. So depending on voltage across port 1, current flowing through port 1, voltage across port 2, current flowing through port 2. Depending on these four parameters, there are different types of parameters we will get, and these are nothing but hybrid parameter. Then we have studied about the admittance parameter. Admittance is exactly opposite to the impedance parameter, because if you see, impedance is nothing but resistance and admittance is nothing but it is the reciprocal of the impedance. Then we have seen hybrid, then we have seen transmission, or we can call as a ABCD parameter. Then inverse hybrid, inverse ABCD, or you can say inverse transmission. It means what? Depending on these four variables, voltage, current for port 1, voltage, current for port 2, we are having the 6 different parameters. Then we have studied how these parameters we can convert into other parameters. Then we have seen interconnection of these networks. How it means what? If we want to connect any network, like if we are connecting the hybrid parameters, if we are connecting ABCD parameter, we can connect ABCD parameter in the cascade form. Like this, we have seen the interconnections of the parameter. Then we have studied about the sorry. Then we have studied about the Laplace transform, which we can use to derive the differential equation in very simple manner. Because if you see, Laplace transform is having lots of advantages over the classical methods, because the differential equation specifying the performance of the complicated network, and we will get the simple solution by using the Laplace transform. And if we are using the Laplace transform, it can give us conversion of time domain value into a frequency domain. That's why we can use Laplace transform to solve the differential equation. And if you see the frequency domain, we are having the value as a complex variable, and we are denoting that value as letter S. S equal to sigma plus j omega, because that variable is a complex variable. Then we want to see about the network function, which we have to study in the today's session. Now we can start our today's session. So if already we have seen, we can convert time domain value into the frequency domain. It means what? If we are having the function like f of t, we can convert that function into the f of s. How we can convert? We can convert by using the Laplace transform. So if we are having the network which is having function in the series form, at that time we can convert that functions into a product form. You can see here how we are converting. K is nothing but it is a constant term. So if we are having the rational function, which is in the form of P by Q function, rational function is nothing but the function which we can write in the form of P by Q, where Q is not equal to 0. So here, if you see, we are writing f of s in the form of ratio, because this an s to the power n up to a0 is nothing but it is a numerator, and what we are saying, it is a p of s. And if you see here, q of s is not equal to 0, so we can call this function as the rational function. So if we are converting that rational function or the series form into the product form, we can convert like this. How we can convert? We are taking an1, n minus 1 up to a0 as a constant term. We are calling that constant as a k. And we can write this value. If we are having s to the power n, we can write s minus z. If we are having the value s n to the power minus 1, you can write s minus z2 like this. And you can use the same method for the denominator also. Here we are using the letter p, and here in numerator we are using the letter for that variable as a z, because it is a complex variable. Yes is nothing but it is a complex function. So if we are having one function, it is somewhat complicated, but if you see one example, you will get the things how we are converting. It is very simple. You can see in mathematics, if we are having any term in the form of ratio, and it numerator is not divisible by the denominator, and numerator and denominator all both are having the constant term and the variable, at that time how we are doing, we are making that term, we can split that term, we can minimize that term. So s square plus 3s plus 2 co we can write in the form of s plus 1, s plus 2 like this. You can convert network functions into the simplified product form. Here, if you see numerator, if you see both terms are in multiplication, and for denominator also both terms are in multiplication. So here we can say, if we are having the network function in which we will get the series form, at that time we can convert that series form value into the product form to get the solutions easily, because by using the Laplace transform we can differentiate, we can solve differential equations easily. You can see here, if we are having the one port network, one port network means what? Can anyone tell me what is mean by one port network? Pranali, answer the question. Pranali,
Yes, ma'am.
what is mean by one port network?
Ma'am, I can't hear you.
What is mean by one port network? Okay. Uh, Pradnya, am I audible to you? Am I? You can answer now.
One port network is a two-terminal electrical network which current enter through one terminal
Okay, it means what?
and leave through another terminal.
Okay, it means what? A network having only one pair of terminals.
One,
Calling
yeah.
that network as a one port network. Very good. Okay, you can make yourself. Now you can see here. We are calling this network as a one port network. Now, we are supposed to calculate here driving point emittance. Emittance means what? It is the common word for the impedance and the admittance. So we know, if we are supposed to calculate the impedance is nothing but it is the resistance. How we are calculating? V by I. like R equal to V by I. Like this, we can calculate in the form of frequency domain Z of S equal to V of S upon I of S. If we are calling about the impedance, and if admittance is nothing but it is the reciprocal of the impedance. So Z of S क्या है? V of S upon I of S. तो Y of S क्या रहेगा? It will be exactly opposite with Z of S. So we will get here I of S upon the V of S. Saurabh, Swapni, you are supposed to join class on time. Huh? Okay, you can see here. So what we are saying here, we are supposed to calculate here driving point admittance and the impedance. We are calling this function as the impedance functions. We are supposed to calculate these functions for one port network. This is the only criteria how we are calculating. You are supposed to solve impedance and admittance. This is nothing but the driving point. You are supposed to calculate driving point admittance and the impedance in terms of RL circuit, RLC circuit, and RC circuit. That's why you are supposed to understand how we are supposed to take for resistor, how we are supposed to calculate Z of S for the capacitor, how we can calculate 1 by SC. And if there is a inductor, we can take S into L. Like this, you can solve driving point impedance for RL, RC, and RLC circuit. We can see one by one. So here, if we are having the RLC, what we are supposed to calculate here, dp is nothing but driving point. So if we are supposed to calculate driving point immitance means what? We want to calculate z, also we want to calculate y. मतलब हमें impedance भी solve करना है और admittance भी solve करना है. So if we are having one network and there is a question like, for given network, find driving point network function. It means what? Driving point network function मतलब हमें क्या क्या कैलकुलेट करना है? We are supposed to calculate dpz, dpy. So dp is nothing but driving point. So if we are calculating z का फॉर्मूला क्या है? V by I. So if there is resistor, we can take directly R. If there is inductor, we can calculate SL. We have already seen these things. You can see here. When we are taking the Laplace transform of the resistor, inductor, and capacitor. If there is resistor, we are taking directly R. If there is inductor, we are taking SL. And if there is a capacitor, we are taking 1 by S. So in that way, we can calculate for this RLC circuit. So if we are calculating the impedance, we will get V by I equal to R plus SL plus 1 by S. And if we are calculating the Y of S, it will be the reciprocal of the impedance. It means what? It is the 1 of Z of S, or we can calculate again separately. I by V, both are having the same meaning. I by V को ही हम क्या लिख सकते हैं? 1 by Z of S. So 1 by that value. You can write separately or you can write in form which you want. You can solve. So this is the network functions for one port network. We can see again some examples. Firstly, if we are supposed to calculate the driving point functions for the two-port network, if you see this network is a two-port network. So now we are supposed to use the equations which we will get for the impedance and the admittance in the two-port network, which already we have studied in our previous session. If we are having the two-port network, we can calculate that impedance as Z11 equal to V1 of S upon I1 of S, and Z2 to S you can calculate as V2 of S upon I2 of S. And exactly reciprocal of these will be for Y11 and Y22. We are calling these as a two-port network function's driving point emittance. Emittance is nothing but Z by I. It means what? Impedance as well as admittance we are calculating here. So we can see example, then you will get the idea. So if we are having the two port network and with respect to this impedance and admittance, we are supposed to calculate the voltage ratio, current ratio, transfer impedance function, transfer admittance function. So how we can calculate? In electronic circuit, we have seen what is meant by gain, what is meant by voltage ratio, current ratio. We are calling these as a gain. So it is nothing but it is the ratio of output voltage with respect to input voltage. But here in electrical circuit, in our two-port network function unit, what we are studying the voltage ratio. That will be in the form of frequency function. So we are supposed to use here V2 of S upon V1 of S. V2 of S is nothing but voltage across port 2. ये जो V2 है, we are calling that V2 of S because it is the frequency function. And V1 of S is nothing but voltage across port 1. This is we are calling voltage ratio transfer function as a forward, and if we are taking its reciprocal at that time we can call this as a reverse voltage ratio transfer function. In that way we can calculate current ratio transfer function. That will be again the ratio of output current with respect to the input current. But here if you see in the two-port network function, we can calculate, we can denote voltage ratio transfer function by letter G of S, and we can calculate G of S as V2 of S upon V1 of S. If you see the current ratio, we can calculate as I2 of S upon I1 of S, and we can call this is as a forward current ratio transfer function. We can denote that by letter alpha. Is there any issue? नया कौन आया है अभी? स्वप्ना निराले, स्वाति पाटिल. Okay. हाँ. So you can see here. हाँ. Now we are supposed to calculate here transfer impedance. Impedance is nothing but V by I. So if we are calculating these for the two-port network, so we are supposed to use the formulas which we are getting from the parameters of the two-port network. So if we are supposed to calculate the transfer impedance, so we are supposed to use the equations for the impedance. So Z21, if you are calculating, you will get V2 of S upon I1 of S. And if you are calculating Z12, you will get V1 of S upon I2 of S. Like this, you can solve. It will be the reciprocal of the transfer impedance, and we are calling that as a transfer admittance. So you can see here, if we are taking the reciprocal of this one, I2 of S upon V1 of S, we are calling this as a admittance Y21 of Y21 of S. And if we are calculating Y12 of S, you will get the reciprocal of Z21. That will be I1 of S upon V2 of S. Now we can see the examples. You can see here. I have given here four examples for RC, for RL, and for RLC. You can see here in in first example. Just see, then only you will get the things. First, focus on this first example, first block. What we are doing here? We are using here resistor and the capacitor. What we are supposed to do? Question is what? Determine the transfer function of the circuit. Is it visible to you? सबको दिख रहा है?
Yes, ma'am.
हाँ.
Yes, ma'am.
अभी क्लियर दिख रहा है ना? स्क्रीन बड़ा किया है तो?
हाँ, ma'am.
You can see here. What we are doing here? We are supposed to calculate the transfer function. For this, the first block में देखो. The question is what we are supposed to find the transfer function, and we are having here RC circuit. So now this is the function in the time domain. ये function जो दिया है वो हमें किस में दिया है? Time domain. But when we are using the transfer function, at that time we are supposed to use the frequency domain. So firstly, we can convert this circuit into the frequency domain. How we can convert? If we are converting the same circuit into the frequency domain, circuit will remains the same, but time की जगह क्या आएगा यहाँ पे? Frequency. And for frequency we are using here later yes. So we are supposed to use as V1 of yes at the input and V2 of yes at the output. And if there is a resistor, we can take as it is. If there is a capacitor, we are taking 1 by SC. So we can take that 40 is in numerator. So 1 by 40, 1 by S, and there will be 1 by 40. So that 40 will go in the numerator. Please don't confuse here. I am not taking directly 40 in numerator. I am taking that value as 1 by SC. So 1 by SC का क्या value आ रहा है मेरे पास? 1 upon 1 by 40. That's why that 40 is going here in the numerator. And we will get 40 by S. In electrical circuit, you are supposed to solve most of questions as a numerical. So if you will get the things, you will get the full marks. Time कम लगता है electrical circuit में, but you will supposed to understand the tricks, which rules we are supposed to use, how we are supposed to convert. At that time only you will get how to solve. So you can see here, when we are supposed to convert that value time domain into frequency domain. Now what we are supposed to do here, we are supposed to use the transfer function. So what we can say here, we can take function here. We are supposed to calculate the value of V2 of yes. How we can calculate? We are having the total voltage because they have given V1 of yes. Actually, they have not given the value, but we can take that voltage V2 of yes in the form of V1 of yes by using voltage divider rule. So if we are using the voltage divider rule, what will be the rule? V2 of yes equal to that value of impedance here. तो impedance क्या है यहाँ पे 40 by yes का? ये यहाँ पे क्या है कैपेसिटर का 40 by yes. We will take as it is in denominator that impedance and the impedance that will be in parallel with this. So we can take total impedance 40 by s plus 4 and into total voltage. We are using here voltage divider rule. V2 of yes equal to V1 of yes into that resistance upon the total resistance. Total resistance, these both we are supposed to take. These are in series, but we are supposed to take total resistance, so we are taking their addition. So if we are converting that value, we are solving, you will get 10 V1 of yes upon yes plus 10. If we are calculating the transfer ratio का formula now we have just seen. What is the formula? V2 of yes upon V1 of yes. So V2 of yes we will get in the form of V1 of yes, and V1 of yes we will read as it is. So V1 of yes cancel हो जाएगा, and you will get 10 upon yes plus 10. So you can convert that equations, that circuit of the time domain into the frequency domain, and you can calculate the transfer functions. If we are having the RL circuit, you can see here, if we are having the RL circuit, similarly the same method we can convert that into the frequency domain. If we are converting into frequency domain, now we are supposed to calculate the values of transfer function. Transfer function का rule क्या है? G of S equal to voltage across output port upon voltage across input port. So you will get G of S equal to V2 of S upon V1 of S. So again, if you are using the voltage divider rule, if we are using the voltage divider rule, V2 of S को तुम क्या लिख सकते हो? V1 of S upon that resistor, V1 of S into that resistor 20 upon 20 plus 2 s. V1 of S both जगह cancel हो जाएगा. You will get 20 upon 2 s plus 20. You can minimize that equation in the form of 10 s plus 10. You can write this equation as it is. You can put here V1 of S. यहाँ पे you will put G of S equal to 10 upon S plus 10 equal to V2 of S. But if we are having, again, you can see here, you can convert that equation in which form you will be needed. Now, if the input is V1 of t equal to 20 for t is greater than 0, you can take V1 of yes equal to 20 by yes, because what we are considering here, we are considering time is greater than 0. So you can take 20 by yes, 20 by yes. So if you are calculating the V2 of yes, so V2 of yes, that will become total voltage 20 by yes into that ratio 10 upon yes plus 10. How we are getting here? We are considering if the input is 20 for the time domain. So if you are taking in the frequency domain, that will become 20 by s. So I am writing as it is 20 by s. So if you are having the 20 by s as V1 of s, so V2 of s क्या होगा? Total voltage into, again if you are using the voltage divider rule, total voltage into that resistance upon the resistance total resistance. So you will get 10 upon s plus 10. Say 10 upon s plus 10 into total voltage 20 by s. So you will get this equation. So you can write this equation in the form of 20 minus 20 e to the power minus 10 t. How we are taking? Because if we are having the Laplace transform, we know e to the power at का Laplace transform क्या है? 1 upon s minus a. So if we are having the Laplace transform time domain, frequency domain value, so we can convert that value into the time domain. So we can put here a 200 नहीं है, यहाँ पे 20 चाहिए. By mistake I have put, I have written here the 200. I have taken that slide na, so there is mistake. Here answer will be no 10 into 20, that will be 200. Yeah, there will be the 200. 200 yes plus 10, and when you are solving at that time you will be get here 200 minus minus 200 by 10, that will become 20. 20 e to the power minus 10. So here only you will be needed the 200. So if you can see here, if the input is having V1 of t as 20 sine 10t, we are considering there is no need to solve these things. I am just explaining how, if they have given the value of input voltage as 20 for t equal to greater than 0, if they are giving at that time, you are supposed to solve this thing. Otherwise this answer is enough. The answer is enough. If they are giving us, if the input is 20 sine 10t for time greater than 0, at that time you can write that equation as v1 of s equal to, साइन को क्या लिखते हो हम, 1 upon s square plus a square. ये जो a का वैल्यू है यहाँ पे 10 है, so you can write 20 as it is 10 upon s square plus a square is nothing but 10 square 100. So you will get 200 upon s square plus 100. For this you will be needed our previous formula, how we are taking the Laplace transform. So this is the constant term 20 we are taking as it is, and sin 20 का Laplace transform क्या है? 10 upon s square plus 10 square, because a upon s square plus a square we are having the Laplace transform for the sine value. So if we are calculating this, you will get 200 upon s square plus 100. If you are again converting these equations and you are calculating the V2 of this, you will get total voltage, input voltage 200 upon s square 100 into you will get 10 upon s plus 10, that will be the total voltage 20 upon 20 plus 2s, so you can write 10 upon s plus 10. So I am directly multiplying 10 into 200, you will get 20,000. यहाँ पे मैंने क्या किया है, 10 और 20 200 को डायरेक्टली मल्टीप्लाई किया है 2000, एंड yes plus 10 I am writing as it is, and v1 yes का क्या है यहाँ पे, s square 100. So again if you are converting that frequency domain value into time domain, you can take that 10 as constant term 10 e to the power minus 10 t plus 10 square root of 2 sin 10t minus 45. But for these you will be needed the formulas how we are taking the Laplace transform. If we are having the RLC circuit, we know how we can calculate the values of impedance, we can calculate values of admittance and impedance. How? If we are calculating here the transfer function and we are having the RLC circuit, if we are calculating the impedance, impedance कैसे calculate करोगे, R plus SL plus 1 by SC, And if we are calculating the admittance, 1 upon R plus SL plus 1 by SC. And if we are calculating I by S, that is nothing but the admittance. We are calling here as a transfer function. You will get 1 upon R plus SL plus 1 by SC. If you are multiplying numerator and denominator by SC, you will get this equation. And you can modify these equations. And if you are calculating for the output, S2 of S, that will be V of S upon Vg of S. So you will get 1 out S square LC RC S plus 1, because SC will get cancelled. क्योंकि यहाँ पे we will take input VG of S, that will be SC. So SC will get cancelled and you will get 1 upon S square plus RCS plus 1. If you are having only RC circuit, how we can calculate the voltage? If we are calculating the impedance, you can calculate 1 by SC plus G. But if we are calculating here the value of voltage, V by I, you will get 1 upon G plus SC. G is we are having here the value. We are given here. So if you are calculating H of S, that will be V of S upon I of S. So क्या हो जाएगा 1 upon G plus S. Like this, you can solve these equations. If anyone is facing any issue, you can ask me. Otherwise, we can stop here. Okay. Thank you. Now I am taking your attendance. Tomorrow also there will be lecture for the electrical circuit. You all are supposed to join that class. I will send the link. Mostly that lecture will be on the same time, 10:45.